how to add a vector. So we know if there are scalar quantities, just like a real number, we can add them, and we know the different rules of addition, right? Same way, how to add a vector. Okay, so there are different methods. There are two important approaches to add a vector. One is a triangular method, a triangle law of addition. What does it say is, if you have a vector, if you want to add two vectors, so for example, there is a vector A and there is a vector B. Okay, I want to add the two vectors. So what I'm going to do is I'm going to place them in such a way that without changing the direction. Okay, so yes. So let us assume there is a vector A and there is another vector B. I want to add them. So what I'm going to do is I'm going to place them next to next in such a way that the vector whichever I'm adding, first vector I'll keep it here, and that is I'm representing by the letter A and B, terminal point be B and initial point be A. Now place the second vector in such a way that the terminal point of the first vector becomes initial point for the second vector B. Okay, so let me name it as BC. So now see here, vector BC is equal to vector B and vector AB is equal to vector A. Now I'm trying to join the initial point of the first vector with the terminal point of the second vector, and let me name this as C. So this says this vector AC, the final result, whatever I got, is nothing but sum of the vector AB and vector BC in the same direction. Okay, and this is represented by C. Vector C is equal to small letter vector A and vector B. This is called triangular law of addition. If the sides of the triangles are taken in the order, then the resultant is equal to 0 as initial and terminal points get coincided. So what do I mean by that? If the sides of the triangle are taken in an order, then the resultant vector is equal to 0. What do you mean by that? Suppose if we take like this, and if we take like this, say they are taken in the different order, right? So let me tell you. Let me show the diagram for this. Wait a second. Let me erase this part. Let's go to the next part of the slide, which might have a proper figure for that. Yes, here. This is what it means. So you have taken the vector like this. Okay, A. And now there is a vector B. There is also another way, right? This is a vector B. So this is represented by A, B, and we know this is in the order. So if you take in the same order, that is a starting point of this is here, and starting point of this is B, and starting point of this is C. Now what happens is, so if you want to understand what is the resultant of this, I'm going to write the same vector in the opposite direction, that is minus B. Okay, and this is A minus B. Okay, so if I have taken a vector like this, and the vector direction of this is here, and if I take the opposite direction, I get the subtraction of that. Okay, that is A minus B. That means here only we understood how to subtract the vector also, right? So here in this diagram, BC is equal to BC dash in the opposite direction. Okay, suppose if you add them, B minus B, you should get what? 0. So that's what it says. That is because if you take these two vectors like this, and if you add them, this is A plus B, this is A minus of minus B, so they get cancelled out, right? So final result of these two sum will be what? Equal to 0. So let's see what is mentioned here. Let AB be a vector with A as an initial point and B as a terminating point, and BC be another vector with B as an initial point and C as a terminating point. Now if we construct another vector BC dash in the opposite direction, then such that BC dash is equal to minus BC. Applying the triangular law of addition, what happens is, let me show you. So we are going to add this. So B Yes. B minus B should be equal to 0. That is, this is A plus B. This is minus A plus B. This becomes addition subtraction. So when you add this, what happens is this is going to become 0. That means if you take in the opposite order, the sum will become 0. As simple as that. So let's solve some questions to make it very clear. So there is another way to add the vectors, that is parallelogram law of addition. Let me discuss that as well. So what is the parallelogram of law of addition is, if you take two vectors as a side placed in such a way that there are two parallel sides of a parallelogram. So this is adjacent sides of a parallelogram, not parallel sides, adjacent sides of parallelogram. Now what I'm going to do is I'm going to write the same vector in this place, place this here, same direction and same name, okay, same magnitude also. And what about this parallel to this? This is B, okay. So now if I want to join this diagonal of the parallelogram from the initial point to terminal point of the given vectors. So this is the terminal common initial point for both the vectors. This is a common terminal point for the both the vectors. Now I'm going to join a line from the initial point of the given vectors to the terminal point of the given vectors. Then what happens is we get the sum of the two vectors. So this is called parallelogram law of addition. Let me read out the statement. If two vectors A and B are represented by the adjacent sides of a parallelogram, then the sum of A plus B is expressed in the magnitude and the direction by the diagonal of the parallelogram from the common point of the two vectors. This is known as parallelogram law of addition. You can either make use of the vector, that is triangular law of addition of vectors, or parallelogram law of addition of vectors to add to vectors. Okay, is this clear? Yes. And let's talk about the properties of addition quickly. Okay. What is it? The first property is, if you add the vectors in any direction, the sum remains same. A plus B is equal to B plus A. Just like any two real numbers, if you add in any direction, it doesn't change anything. If you multiply any two numbers in any direction, it doesn't change anything. So what is this property called? It's called commutative property. That means the order in which you are adding, it doesn't make any difference. So which is always helpful for us if it is commutative. So not every operation is commutative. So this is a commutative property. Okay. Addition of two vectors in any direction doesn't matter to us. Okay. There is a proof of this. You can check the proof of this clearly. Let ABCD be a parallelogram. ABB represented by small letter A and BCB represented by small letter B. Then this sides is A and B. This is again B as well as A. So when you add this, since the opposite sides of parallelogram are parallel and equal, AB is equal to BC. So AB is equal to DC and AD is equal to BC. Then by applying the parallelogram law of addition, we get AC. AC is equal to B plus A, or same AC is equal to what? A plus B. So it doesn't matter in which order you are adding. A plus B is equal to B plus A. So it is commutative law, right? So remember this property. And next one, we have associative property. So how is it shown? What is associative? If you are adding any two numbers, I'm associating B with A and then I'm adding to C, or I can associate B with C. Okay, so this is called associative law. The same holds good for multiplication of any real number also. AB into C is equal to A into BC. Same way in a vector also, which says associative law holds good. For example, here you can see a vector A, okay, and another vector B. Its sum is A plus B. Now I am going to have C here. If I add these two, this is A and B, so this can be C, right? So same way, if you add A and directly you add ABC, So it can also be written like this. So we can represent in the triangular method as well. But try to understand this can be added in any order. It doesn't matter. Okay. So that means there are two things we understood. A vector addition is commutative in nature, and vector addition also follows what? Associative. It has associative property. Okay. And remember, zero vector is a vector which doesn't have any magnitude. So when you add a zero vector to any vector, you get the same vector. So what is zero vector called? Additive identity of a vector addition. Okay, it is an additive identity for vectors. If you want to add something and if the vector should not change, means that is nothing but zero vector. Remember that? Yes.